Alright, so let's say given this diagram of a tractor pulling wood planks, and the question says, a tractor pulls a block of wood 20 meters along level ground. The total weight of the tractor and the wood is 1,400 newtons. The tractor exerts 500 newtons of force at an angle of 30 degrees, and a friction force opposes this motion with a force of 50 newtons. Find the total work applied on the wood. So how exactly can we solve this question? So we start off by drawing a free body diagram for the situation. We're going to be looking at the wood plank. So we're going to have the normal force. There is an error in the question here. It's just supposed to be the weight of the wood being 1,400 newtons. So we write that down. Sorry about that, guys. And then it says there's a 500 newton force at an angle of 30 degrees. So you can write that down as the force applied. We have a force of friction, 50 newtons, opposing the direction of motion. So it's going to be in this direction here. Note that displacement of 20 meters is in the right direction. Now we can apply our equation here where F is equal to the sum of force along the direction of delta x. And delta x is just a displacement. So to find F, we can look at the sum of forces. We're going to look at the sum of forces in the x direction since this is the direction of displacement. So we're going to have the force of friction going to the left, and then we're going to have F of x, which is the x component of the force applied. We can find it by using trig, where cos theta is equal to adjacent over hypotenuse. Since F of x is adjacent, if we plug adjacent and hypotenuse into our cos theta equation and rearrange, we get this expression here. So we can plug these both in. Remembering that force of friction is in the opposite direction, so it's negative. And we can compute the term on the left. Cos 30 is going to equal 0.7, and then we can multiply that by the amplitude, and we get this. We do a simple subtraction and get this for the final answer. So this is going to be the sum of forces in the x direction, and it represents F in our equation because F is the sum of forces along the x. If we plug both these values into our work equation and do a simple multiplication, we get this for the answer. So this is the net work being applied on the wood planks by all force. If we look at our diagram here, we have delta x equals 20, force applied 500 newtons, and then we have the force of friction 50 newtons in the other direction. With the work being involved moving the planks 20 meters is going to be 7,700 joules. Note that the network is positive, and this makes sense since the net force is positive and along the direction of displacement. The second note I just want to make is that the work done by friction is negative. This negative work brings total work down. So if we just look at the work brought by friction, we apply our equation here. So F is going to be negative 50 newtons. Delta x is going to be 20 meters. Our final answer here is negative, and this makes sense because the force of friction is opposite to the displacement direction.